5.7 integrals and inverse trigonometric functions. If we recall about the derivatives of inverse trigonometric functions, we had something to the effect of the derivative of sine inverse of x was 1 over the square root of 1 minus x squared. And then that followed with cos inverse being simply the negation of that result. And we saw that the cofunctions to these inverse trigonometric functions had derivatives which were only different by a negative. Right? This will be important for this section. Derivative of tan inverse, and this is an extremely important one as you move into Calc 2 as well, 1 over 1 plus x squared. And then again, since cofunction inverses have derivatives which are simply different by a negation, we had negative 1 over 1 plus x squared for the derivative of cotan inverse. So then you have the other two cofunctions. We had cosecant inverse, which was 1 over magnitude x squared minus 1. Only that one was negative. And then we had the one for secant inverse was the positive one. But the same structure. Magnitude x, root of x squared minus 1. All right? So if that's the case, then when working backwards from these types of structures to an antiderivative, which would be an inverse trig function, for example, if we had the antiderivative of 1 over the root of 1 minus x squared, it has to follow that this is sine inverse. But if it's this structure that I'm concerned with, then if I came across a problem where there was a negative in here, then it really wouldn't matter that I said it was the cos inverse specifically as the result, right? So because these only differ by a negative, then when dealing with the reverse procedure, whether this is a negative or doesn't have a negative, right? I can always adjust by a negative. And I can just slap a negative on here. If this was negative, I could just put a negative right here as my answer. And so I don't need 6 different results because 3 of them only differ from the other 3 by a negation. So I need this one, really, or one or the other, but I'm going to pick the positive one in each of these cases. Okay? So we have this result we need to keep track of. We have the secant result, secant inverse result, 1 over magnitude, or not magnitude, depends on the values in the limits integration. But here, x squared minus 1 dx with a secant inverse. And then the tan inverse will take care of the other pair, again, because they only differ by a negative. So if any of these structures appear in an integral I'm trying to evaluate, I don't need to think about all 6 results. I only need 3 of them. And I can always adjust by a negative wherever necessary. Right. So these are the three main ones to keep in mind. And I'm going to approach all of the upcoming problems in this section through the chain rule, as opposed to the way the book does. The book has a certain formula for special cases. I prefer to use the algebraic approach, and chain rule, it's very instructive and helpful for a wide variety of problems later on as well.